Hi friends, let's solve this Thevenin equivalent circuit problem. This is the somewhat complicated problem when compared to all other previous problems we had already solved in this section. So here we need to calculate Thevenin's equivalent across this load RL. Let's calculate that. First we need to calculate RTH, R Thevenin. For that we need to short circuit the only voltage source. So let's do that. Here is a short circuit and here it is 680 ohm resistance and here it is 2.2 kilo ohm resistance. Here clearly this 1 kilo ohm resistance and 4.7 kilo ohm resistance both are in series, so we can replace it with a single resistance, that is 5.7 kilo ohm resistance, and below here it is 2.2 kilo ohm resistor. Clearly this 680 ohm resistor and this 2.2 kilo ohm resistor are in parallel because one end of both these resistors are connected at this location and other end is connected at this location, these locations. So clearly these two resistances are in parallel. Let's calculate that. What is the resultant resistance? I'm using a calculator, Casio. The parallel combination of 680 ohm with 2.2 kilo ohm resistor gives 519.44 ohm. So let's simplify for further. This is the open circuit. This is the 5.7 kilo ohm resistor. And this is the 519.44 ohm resistor. This is connected here and this is connected here. 2.2 kilo ohm resistor. It is 5.7 kilo ohm resistor. This is RTH now. So clearly the 2.2 kilo ohm resistor and 5.7 kilo ohm resistor both are in parallel. So let's calculate what is the parallel resistance of 5.7 kilo ohm resistor and 2.2 kilo ohm resistor. So which is 1.58734 kilo ohms. 5.7 in parallel with 2.2 gives 1.5873 kilo ohm. So let's simplify the circuit. Now the circuit looks like this. .5873 kilo ohm. Here it is 519.44 ohm. This is RTH. Clearly RTH is equals to 1.5873 kilo ohm plus 519.44 ohm. So RTH is 1.5873 kilo ohm plus 519.44 ohm. Clearly it is 2106.78 ohms. Now let's calculate V Thevenin, which is the open circuit voltage across the load RL. So for that let's draw the circuit again. entire circuit again. This is 5 volt source. This is 680 ohm resistor. This is 2.2 kilo ohm resistor. Here it is 5.7 kilo ohm resistor, because we already discussed this 1 kilo ohm resistor and 4.7 kilo ohm resistor, both are in series, so that we can add up. And the final one is 2.2 kilo ohm resistor, and this is this voltage, let's say it is VTH, V Thevenin. Clearly V Thevenin, let's mark this voltage as V1, this voltage is V2. V1 is voltage across 2.2 kilo ohm resistor, and V2 also voltage across 2.2 kilo ohm resistor, but it is located in other branch. So by voltage division method, we can simply write V1 is nothing but 5 over 680 plus 2.2 kilo ohm is nothing but 2200 multiplied with 2200. Similarly, V2 also we can write 5 over 5.7 kilo ohms, nothing but 5700 ohms plus 2200 ohms multiplied with 2200 ohms. So let's calculate what is V1 and V2. So V1 is 2200 divided by 680 plus 2200 multiplied with 5. It is 3.819 volts. Similarly, V2 is I am calculating using a calculator. It is 1.3924 volts. So VTH is clearly V1 minus V2, which will give us 2.4265 volts. This is the required V Thevenin value. Let's draw the, once after calculation of VTH and RTH, it is very easy to calculate, draw the Thevenin equivalent circuit. 65 volt in series with a resistor. How much is the resistance? R Thevenin is 2106.78 ohm, and here we can connect the resistance RL. This part, this left side of the part is known as Thevenin equivalent circuit. That's it. Thank you.